welcome. We're going to talk about GitHub Actions today. So we'll spend a bit of time just kind of talking through why you would want to do this, what is it good for, how would you make use of it, and then I'll show you a couple examples of like how you might do things manually in order to manage package versions or script versions or profiles, whatever, on your devices using an MDM. And then I'll show you how we can automate a lot of those processes using GitHub Actions. Okay. So for introductions, my name's Weldon Dodd. I lead our global solutions team at Kanji. We're an MDM and security tools vendor for Apple devices. I put Noah's name up on the screen as well because he's been really instrumental in building a lot of the tooling that we use at Kanji to automate processes, and he's built some tools that customers can use to take advantage of this. I've also got Mike Boylan from our product team who's over here. You probably saw Mike's name on the schedule, and it just didn't work out where last week we have a company-wide wellness week, and so really it's my fault for not being available to collaborate with Mike, but Mike's been super helpful in building a lot of the cool functionality that you'll see in Kanji, including assignment maps that'll come up later. So I want to be clear too about my intentions here. I am going to use Kanji in my examples to show you like an MDM tool and how it works. But all of the work that we're going to do, all of the things we'll look at with GitHub Actions could apply to any other MDM product. So if you're a Jamf Pro customer, Mosel, or whatever, you should be able to apply everything that you see to your own environment. You just need to make some changes to the API endpoints that you would call, and maybe some of the maybe some of the details would need to change to work with a different MDM, but all the principles should apply. Okay, so I'm gonna spend some time in Kanji and showing you what the Kanji interface looks like and whatnot. But my intention is just to really speak about any tool that you would use to manage Apple devices, not just us. Okay. So automation. Why do we want to automate processes that we use to update configurations for devices? Maybe that's packages, scripts, custom profiles, other things like that. Why automate it? We have GUI tools, right? I can open up a web interface and do all the things I need to do. Why automate any of it? Any thoughts from the audience?
Saves you a lot of time, and not like just for you, but for your team or for other teams.
Okay, saves you a lot of time, might save your team a lot of time. I like that.
Saves you from like copy-paste errors and small mistakes that you might forget.
Saves you from copy-paste errors. This is one of the main reasons that I use Git, is because I can track all the mistakes I make, right? Okay. Standardization. All right, and what do you mean by that? Can you elaborate a little bit?
If you're automating some type of like template or something like that, it's always going to be the same because it's coming from the same source.
Okay, consistency, right? That definitely helps with, the comment earlier about communication across teams. If you have a consistent process that everyone follows in order to update something, that saves a lot of time with troubleshooting, with communication, any kind of misunderstanding about what's going on. Having that consistency is really key. Okay, in the back.
What if you're at a conference and don't want to worry about it?
What if you're at a conference and you want to put it out of your mind and not worry about it? Yeah, I mean, that's a fantastic reason. Our jobs are so busy, right? I guess at this moment, I realize I haven't really done a full introduction of myself, or even a short one. But my career as a Mac admin goes back 30 years. I started at the University of California. I ran a Mac lab and a Next lab at the time when those were two different things, right? And I took a journey in the wilderness in wireless telecom for a decade or so, working on network management systems. But I've been back focused on Apple endpoint management for like the last 15 years. I've been at Kanji for just over 4 years. I joined at the seed round, and while I was at Apple, I did training and worked on macOS Support Essentials. I was the course developer for Apple Deployment Essentials, which is like the MDM course. And I did professional services work with some very large customers. One of my colleagues is here in the room. We worked on a very, very large customer together. That whole experience is important to me, right? I really feel strongly about being a Mac admin and what the role of a Mac admin should be, and the work that can be done to help improve the outcomes of the organization you're working at. That's a very kind of generic, buzzwordy way to say, like, I think our jobs matter, right? I think we can do work that matters. And so this comment that just came up a minute ago about trying to automate things, not worry about it, have things go on, that applies to all of us in the sense that you have important work to do. You have things that you can do to drive the mission of your organization. And look, I'm going to take a flyer here and just guess. If you have a mission statement up on the wall for the team that you work on or the org you work at, it does not say update Chrome or patch Chrome every day, right? That's not the mission of the org. So if you can automate that part of your job so that you can have time to do things that matter, or time to do things where your unique skills and experience can be applied to add more value to your team, that's where you want to spend your time. Not on doing the tedious stuff, right, that could be automated. If you could get that off your plate, not only could you pay attention while you're in a session at a conference, but you can spend the rest of the time you have during your work week focus on things that matter. They're going to help your org move forward, be more successful. So lots of great ideas. Thank you for all of that. When we look at automating processes, there's definitely a few things that really resonate with me. One is the time bit, right, and creating, freeing up some time. But what I want is I want consistent, reliable, repeatable processes. I want things to be documented and, if possible, self-documented in the sense that you could go look at what's been done and follow the trail and understand it. Like someone new to the team could come in and take a look and read it and follow along and get what's going on. That's what we're going to try to accomplish today, right? Is to create something consistent, reliable, somewhat self-documenting. Commit messages matter, all right? So you do have to type those in, but to get the results that we want. So this has always been really important to us at Kanji. So just a couple examples of things that we've put into our product. We have a device name item where you can just select the components that you want to use to configure what the device name pattern should be, right? And it will, here I've done a silly example. This one drives Armin, my friend Armin, crazy because it uses PII in the device name, but that was the example I had. So this works on all those different device types. So you see the little icons across the top, Mac OS, iOS, iPad, etc., Apple TV. So on iOS, it's an MDM command, right? On Mac OS, it's a command line tool, but we've abstracted that away. You just specify what you want the name pattern to be. Kanji takes care of implementing the name in the appropriate way for each device. And you don't have to worry about, do I need to write a script? Did it change in Mac OS Sequoia, or is it going to change next year, right? There's just a little bit of automation that can help out. Another one is home screen layout. So we've got, home screen layout's been around for a while. It's nothing exciting, but we built a visual tool to do it. So you can just drag items in, see how they're arranged on the screen, and then save that home screen layout knowing that this is what you're going to get on the device. because the alternative has been like create a list of items. You hope they appear on the device in that order. You have to push it and wait for it to update. And then if you made a mistake, right, go back and change the list or reorder it and push it again and wait for it to show up. So just being able to see tools like this really quickly is helpful. Another example is File Vault. So again, old hat. File Vault's been around for a while. But one of the details that we've added is, just a single checkbox for key escrow. And what that means is we look at the device. Is File Vault enforced? Yep. Are we supposed to escrow the key? Yeah. Do we actually have the key in escrow? If not, let's take all the steps. Let's automate the whole process to get that key and put it in escrow. Now, if you're coming from another tool, if it was encrypted previously to enrolling in an MDM, you might know that the key is not encrypted with the MDM provider's certificate. So you can't escrow it. We need to protect that key on disk. So it has to generate a new one. With some other tools, you might be writing a custom script to prompt that regeneration or do something else. There's different scenarios where the key can get generated. It could get generated at the login window. It could get generated with the user prompt. We put a lot of effort into automating that whole process so that as an admin, you don't have to worry about it. You check the box to escrow the key. Kanji takes care of doing all the checks, verifying that it's escrowed. If it's not, we do the right thing. We either regenerate it at login, encrypted with our public key so we can escrow it, or we prompt the user to enter their password to regenerate the key. Whatever's needed, we get it done. These are good examples of things that just save time. So one more feature in Kanji I'm going to show you, and this is going to play out into how we're going to use GitHub Actions to update our configurations. Okay, so assignment maps is a feature here that you can use to, let me make this bigger, that you can use to design your deployment. So in this example here, I've already started one, so you can see it a bit, but I'll zoom in so we can take a look here. This map you read from left to right. So what's happening is in this first block here is for all devices. So, let's just pretend this is a Microsoft shop. We've got all the Office apps and some other stuff in here. Those apps are going to be deployed to all devices. Now, I could add, additional nodes here, additional blocks, right? And scope items to a department, something like that. Let's pick a, user department, and I don't know, contains staff, right? And then I could pick something like Adobe and drag that into the map here. And now if that matches, okay, that item will get deployed. I've added another block down here. It will proceed down this path here. I've added another block here where it's dependent on having a tag assigned to a device. So if it's in this early adopter group, I'm going to deploy this PSU script. And I'm using this script here, this PSU script, as an example of something you might do in testing. So I want to try this out on a small, like canary group of users and make sure it's working right, it survives in the wild. I tested it already on some test devices, maybe my own device. Now I'm ready to test to a small group to make sure that it's working. As I go through and iterate on this script and make improvements to it, or maybe I found an error that showed up in testing that I hadn't seen before, I have to add a new catch to it to accommodate for that, kind of plan around that error. I want to make changes to it and iterate on it and push that updated script out to the rest of my users. But I don't want to necessarily log into Kanji, go to the web interface, find the library item, click edit, open up the box where the script goes, and like copy and paste the script into that box. I want to work on my script in a Git repository where I can track changes and see what's happening and document what I've done for myself, so I know what I've done in 2 days from now, and also for my team, so they can see what I've done and understand what's going on. So, just to kind of show you an example here of that manual process, I'm going to open up just a terminal window, and let's make this plenty big so we can see it. And, if I wanted to, I could, actually, I think I've already built this. So let me go to my auto package folder here, and I'm just gonna delete the package I've already built, so you can kind of see it's all real. I could use this tool kpackage, which what it does is it will take I did the wrong thing. Let me go. It's looking for this the package, and it's going to upload it to Kanji. That's not exactly what I meant to do. So if I go back to auto package here, which is what I meant to do, is actually like build the package. Here's a great tool that can automate a lot of processes for me. So I basically told it to run this recipe. We'll see how Wi-Fi does here. But what it'll do is it'll go out and look for the latest Chrome version, download the DMG, take the .app bundle out of the DMG, and put it into a package. So it's ready to use in my MDM of choice, right? And so looks like it's moving along. But if we go look in the folder here, you can see the DMG. It's almost done. It's 200. It's just over 200 meg. So it's downloading the DMG. It's going to then take it, extract the application out of it, and then it's going to take that app bundle and it'll put it into a package file for me, which I've now gotten. So here's a great tool that's automated part of the process for me. It will always go get the latest Chrome, make a package for me that's ready for me to use. It's done some other kind of helpful things, right? Like setting the name of the file to the version number, right? So that I can quickly identify it, somewhat self-documenting in that it's more helpful than just having Google Chrome.app and having to go like look at the, inside the bundle and find the plist that has the version number in it, or maybe I could get it from the info window, right? And go look at this manually. Putting it in the file name is a nice little automation that saves me time and helps me out. So now that I've got this this package file, let's So now I can use this other tool to actually find the package that I've just built, and I can upload it into Kanji. So this is a command line tool that my colleague Noah wrote, and what it's doing is it's just taking the path to this Google Chrome package that I built with auto package, and now it's going to send it to Kanji for me automatically. If something's gone wrong. But if we go look here in Kanji, like I could, let me save my changes. If we go look in my library of items that I've got, I can, I've got items in here now, right? So kpackage has created this one for me. There's a different way to do it with auto package. It kind of uploads it automatically for me. And so, if I go look at this, right, here's the info, here's my package ready to use. And if I go back into my assignment map blueprint here, I could use those items. So trying to find the, oh yeah, thanks. this is why I need Mike. If I wanted to add a block here, see, you can kind of see the manual steps, right? Let's say, I want my early adopters here to get, the latest version of Chrome immediately. And so I'm going to check the box here and use that early adopters tag. And now I can go look for Chrome and find, the one that Kpackage added and install that. So it was great that I automated part of the process, right? And got auto package to download it and build it and get it ready for me. I used that Kpackage command line tool to upload it and do it. But, I've still got to go edit my assignment map and make that available and set those options. If I wanted to repeat this, right, what I would want to happen is for my tooling, if there's a new version of Google Chrome that I want to deploy to early adopters, I want to update the existing library item that has Google Chrome and update that with the latest version of the Chrome installer. And now I don't have to touch my map again. It's already set up, right, for early adopters, and I can just create this repeatable automated process where the very latest version gets applied and updated, and now everything's good to go. With you could repeat this like with profiles or anything else. So an example we were talking about earlier is like this is testing season, right? So log into Appleseed, look at the testing plans for macOS and iOS or whatever you support, right? And there's things in there that are really important for you to participate in and help out and provide feedback to Apple early in this process so that we get things tuned up for iOS 18 and macOS Sequoia before the fall. And so using those testing plans you might chart out, here's a few things I want to do. You can use that to great effect. So now let's look at our scripts, right? We've seen kind of this manual process or hybrid where I can automate part of it, but I've still got to upload pieces or go and configure something in the GUI. How can I go end to end with a process where I can make a change and have that be pushed right into my working configuration in my tool? So that's where we're going to start looking at Git and some options there. So I'm going to go back to terminal, and I've set up a folder here, a repository for custom items. And so I've already initialized Git in this folder, so it's working as a repository. If we want to kind of look at what's in it, you can see I've already set it up with the Git configuration, so some of the items in there. I've already connected it to a GitHub repository, so I've kind of skipped some of the early steps here in getting things set up. I've set up a git ignore file because I created a .dsstore file. And then I've got a few things here like this folder check directory and a profiles directory. So this folder check script is the one that I want to show you how we can update that in the map that we were just looking at. So if I go back over here and I'll try to zoom in, okay, here's that folder check in custom scripts. So you can see that's assigned. If I go look at this in the library itself, okay, there's a bunch of options you can set. Where is it being used? When does it run? What category does it show up in self-service, etc. But what I'm really concerned with here is the script itself. What is it that's going to run? So you can see here, just to zoom in, last updated, by myself at 1:15 a.m. I didn't do it at 1 a.m. It's just I changed it from p.m. to a.m. for the demo here. Okay, so I wasn't up that late preparing for this session, but there you go. Sure, yeah, okay, yeah. Okay, so I was up late watching Dark on Netflix, which is a good show. I could recommend. It's in German. Just watch it with the subtitles, but it's actually pretty cool. Okay, so 1:15 a.m. was when this script was modified. So what I want to do now is take a look here in my repo. I'm going to move into the folder check where this folder check script lives, and you'll see two items in this folder. So folder check.sh, the script itself, and folder check.json. We'll follow up on that later. But if I look at the script, okay, 1:15 a.m., just highlighting that to keep me honest, okay? So if I modify this, okay, let's go down here and change this to PM. Okay, now my script it's been changed. Okay, let's just imagine I've made some more substantial change, like I actually added some value here and wrote a few lines, or added another edge case to check for, and really smart and sophisticated tests in my code to make it work better. I've made a change. Okay, so if I look at my Git status now, it tells me, okay, the folder check.sh file has been modified. So my workflow now with Git is I'm going to add that file. So I'm just going to use the dot shorthand, which means add all the modified files. And now I can commit that change, and I'm just verifying I'm on the main branch here. And I modified the script for the PSU session, okay? So now I've committed that change. Like I've done my testing, I know that my fix works, I'm ready to commit it and push it into production. And so now what I want to do is send that change up to my GitHub repo. So I use the command there, git push origin main. That will send it up to GitHub. So if we take a look at this, the online repository here, the remote repository for these custom items, okay? And we could see the same thing. So if I go and look inside folder check and I look at the folder check.sh file, you can see here, sure enough, right, it's been changed AM to PM. Let's just imagine it's more substantial, okay? Let's go look at kanji. So still says AM here, but let me refresh the page. And if everything has worked correctly, hey, look at that. It says PM in kanji, right? Well, I never logged into kanji. I never went and took the script and put it there, right? So what happened? This is where GitHub Actions come in. So let me show you that. So if we look at the GitHub repo, okay, I've got my code here on this screen. There's another tab up at the top that has actions. And actions are driven by some configuration in the repo that I'll show you in a minute. But we can look at this last commit here, modified the script for the PSU session. That should sound familiar. That was the commit message that I typed in. So this commit is named here. It's run this workflow inside GitHub Actions, and we can take a look at the way that this, or what's been done, and then we'll look at how it was set up. So the first job here, the first action that's taken is it starts a runner. So this is essentially think of it as like a virtual server, right? A cloud computing resource that you can take advantage of in GitHub. And GitHub provides different kinds of runners. So the most common one is Linux. So you can tell GitHub to spin up a Linux runner, and it will then, inside that Linux environment, run whatever commands you tell it to run. So if you're familiar with bash scripting on Mac, right, you should be able to transfer a lot of that over to bash scripting on Linux. You can also get a Windows runner. So if you have something specific to a Windows environment, there's a Windows executable you need, you could do that. They also have macOS runners. So if you want to, you could do macOS specific things as part of your GitHub workflow. But for the example here, we just are using a Linux runner because we're doing some straightforward things in bash to manipulate the files, the script file that I've edited, and to make an API call to Kanji to push it in. So all this gets set up here. I'm going to skip through some of the details, but you can see here, okay, it's using a couple other actions. So I'm calling additional actions that are available in the GitHub marketplace. So other people have done some work for me, right? This is another great way for me to save time, is to borrow other people's work. And so one of them is built in, this checkout action. So what it's doing is it's going to check out the repository. And then this one, TJ Actions, someone in the community wrote, and it identifies the changed files within the Git repository. Now, the first thing that happens is it runs git checkout. And it's just like at the command line. When you do a git checkout on we're using the main branch here, it grabs all the files that are part of that snapshot and puts them in the working directory. So that's exactly what happens here. The Linux runner that's up in the cloud, this compute resource that I have available to me, it has checked out the main branch of the repo, and it's put all of the files in its working directory, so up in the cloud, right? That Linux runner. So it has all of the files including the script that I changed, but it has all the files in the repo. All right, now this next step is to get the changed files. So again, I've used this community action that's available for people to borrow and use in the GitHub Marketplace. And it kind of does what you think it's going to do, right? It does what's written on the tin. I have provided some filters, and I'll explain this a little bit later on, but I'm only looking for files that end in .sh or .zsh. If I change the README or something else, or I change a text file, I don't want to run through the whole process of like looking at that file and seeing if I need to upload it to the API or whatever, because I already know that I don't. I just want to identify script files in this example that are going to get uploaded. So it looks through all those. There's some other flags and options that could be used. And I'm scrolling down here. Yep. And if we look at the changed files, you can see it's got the Git directory. It was triggered on the push event. It's telling you here it's retrieved changes between these two snapshots. So the commit that I just made and the previous commit. It's looking for anything that's changed there. Here, this step is all done. So now it passes its results into the next step here. So for every file that's in all changed files. So if in this example I only modified the one, right? But if I modified several script files and had multiple changes and committed all of those changes at once, it would follow the same pattern. Does a git checkout, puts all of the files from that snapshot from that commit into the working directory. It compares those files against the previous commit. Anything that's been modified or changed, it builds into a list. And then for every file in that list, I left out, it does filter for .sh and .zsh, but every file that goes through that filter and passes through, it's going to run these steps on each file in that list. And so you can kind of see here the steps that it's going to go through. And I'll end up showing you this twice, okay? But there's a little bit of logging here. It echoes the variable file here refers to the name of the file. So it just logs, hey, this file was changed. Now I'm doing some interesting things with this JSON file. So I'm grabbing a few configuration details that I need, and I'll show you how this is done. But I'm grabbing the ID of the item in kanji, what kanji thinks the ID of this item is. If you're working with Jamf Pro or any other MDM, there's going to be a unique ID to reference an item in your MDM. And so that's what's being used here. I have the unique ID for this PSU script that I put in kanji, and I'm referencing that ID so that I can update the existing item. I'm building the data, which is like the payload that I'm going to send to kanji in the API. And I'm going through some steps here to take the script and manipulate it a bit so that I can prepare it to use in the API call. And I'm going to come back to this as well. Then I'm building out the JSON for this API call. So these different items that I just talked about, you know, the ID, the data, the script itself, and I'm putting all of that together into an API call. And you can kind of see some of the details here. It's using JSON. This is the data payload, is this JSON that I've built in the previous step. It's calling my personal instance here, this endpoint, with the ID of the item. And all of that then gets sent up. So it grabs the changed file, folder check.sh, and then here's some more logging just to show you kind of the result. So it has the ID of the item, some additional data, so some additional options are being set. The execution frequency here, no enforcement, means self-service. So it's not going to run automatically, it's going to run in self-service. It won't restart, and then the script part of the payload is the actual script itself. So this is where you'll see the last update by Weldon at 1:15 p.m. Okay, and that's the message that's being sent to kanji after it's gone through this the GitHub runner that's done all this work to prepare the file, right? Figure out what's changed. Is this a script that I want to send? What other details do I need to gather up about this script? And then the final result here is the GitHub runner executes this API call with curl right here, and it patches or it updates this item in kanji. And then there's some post-run stuff where it just it logs that it's successful and what the result was, blah, blah, blah. And there we go. We're done. At this point, the cleanup means that the GitHub runner is spun down, it's finished its work, and that's it. We're all done. So you get the benefit of having access to this ephemeral, on-demand cloud compute resource that will do a whole bunch of actions for you when you trigger it, run its job, and when it's done, it spins down. Now, it does consume some resources. GitHub will charge you for this. You can figure out the pricing is reasonable, right? So with with the demos that I do and like the changes that I make, a couple changes a day, whatever, I never get an extra charge. But, if you have a big shop and you're using lots of data and you're making tons of API calls, it's something for you to consider. I just want to mention it so you don't come back to me in a month and say, hey, Weldon, I just got like $1,000 bill from Git. What's going on? Pay attention to, their pricing and how they do it and how they charge for those resources. But this kind of operation is really lightweight. And so it's pretty efficient and easy. Okay. So I've kind of talked through that process. I'm going to show you 2 more things. So, well, maybe more than 2, but here are the next 2 things I'm going to show you, right? I want to show you a little bit about how this GitHub repository is set up so that you can use this. And then I'm going to show you how this GitHub workflow, the actions workflow is configured and how I designed it and how I built it to run the way that it did. So a couple things here. Setting up a GitHub repo itself, I'm not going to cover. They have great documentation, and you can look that up. Now, I do have branch protection rules set up on the main branch. So what that means is you might think, hey, it's kind of dangerous, right? If someone commits a change to my repo, it's going to go straight into production. Yeah, that's how I set it up, right? If you make a change and commit the change in this repo on the main branch, it's going to go right into production. What I've done, though, is in GitHub, I've implemented main branch protection. So if someone else on my team commits a change to this script, it's going to show up as a pull request in GitHub. And I'm going to have to log in as an admin, or you can configure this multiple different ways, right? But what I've done here is, require the pull request before merging. I've required 1 approval, but you could set this up for multiple approvers, and you can choose who you add to the approver list. So, and just to be clear, like if you use GitLab or some other hosted Git service, like these are similar things you could do with those services too. So these ideas are transferable. But what I wanted to do was make sure that I have a flow here where if, maybe I've got an intern or a junior associate or something working on my team, and I want them to cut their teeth and learn stuff and try it and get going, but I want to review their work before it goes into production, okay? I can do that. They can make the edits, they can, if they feel like it's all working great, they can commit that to the main branch, and this flow will generate a pull request in GitHub that then I need to go in and approve before it actually shows up in production. You could require multiple approvers, do all that kind of stuff. But this is an important part of the process, right? You probably don't want to set it up so just anyone can push stuff straight into production. There's a bunch of other options in here too, but I am going to skip over those. Yeah.
I imagine it's pretty reasonable though to maybe you have another branch that's for testing, and like that same person could have that set up in a way in which it's scoped to some test devices, and they could push, and a workflow would trigger for those devices automatically.
Yep.
But then to merge to main, you'd have to approve it.
Yeah, it would. To try to illustrate this point that Mike is making, it is possible to work on different branches, and I could configure my GitHub action to have different targets depending on if the commit was on the main branch or like a development branch or a testing branch or whatever. And those could be 2 separate items in my MDM, and it would update the appropriate item. Now, you'd have to control the assignment or scoping of those items, but you could imagine it with what I've shown you already with the maps, where I have an early adopters set of items, and I could have the development branch, push and update that item that's available to early adopters, and I could have the main branch push and update an item that's available to everyone or is enforced for everyone, that kind of thing. Okay, so there are lots of ways to get very sophisticated if you like, but we'll here we are. Okay, there's a bunch of other options you could do here, but I'm gonna skip over those. Actions. So actions is where this GitHub runner and all that happens. So this does need to be enabled to allow actions and allow reusable workflows. There's a bunch of other things you can do here around permissions and access and whatnot. Okay, but let's look at the action itself. So in the GitHub folder here, so this is a folder that GitHub adds to the repository. There is a workflows folder, and inside of that is a YAML file. This is where you do all the configuration for your GitHub workflow for this action. So let me show you how this was put together. And we'll go with this. Is that okay in the back? Good enough? Okay. Okay. So I'm going to walk through how this was built, and there's these examples on GitHub as well that you can use to kind of follow along or build your own. But I think it'll be helpful just to walk through how this one is constructed so you can get an idea of how you would build one. So first thing is just the name, right? How it shows up in the interface. This on section is listing the triggers that are being used by this action. So when is it going to run, basically? And there's two things that, there's two places where it's going to run. It's going to run on a push to main or a pull request to main. And then the jobs, this is a list of steps that it's going to take, right? This is where the work gets done. So the first one, the first job, the name of that job is changed files. That's how it'll show up in the log. I'm picking the environment that my runner is going to use. So in this case, Ubuntu. The environment, I'll show you, is, think of it as like your environment variables in macOS in the shell. So what environment is GitHub going to refer to find variables? And the variables are going to be important here. There's a name for this, test the changed files. It's going to check out the repo. The fetch depth here is, it's just looking back one commit. So we're comparing the previous. It's going to run this action. Again, the TJ actions, so the author here, this is their action, and then, or this is their like folder of actions, and this is the specific one that I'm calling. And I'm only using this option here to filter the list down to only get the .sh and .zsh files. So this is a set of instructions for this Ubuntu runner. Do the checkout, run this other action to compare this latest commit with the previous one, filter that list of files down to only the .sh and .zsh files, and make that list of files into an array that I can use in the next step. So now I've got a list of all the changed files. If I put this step in here because if the result is nothing, no shell file or no Z shell file changed, it's just going to exit and not do anything else. So the reason for doing that, I guess the reason for doing that is so that you could just exit early. No reason to go through all the previous or the following steps if there are no files to be uploaded. But here's that. Here's the script that I showed you earlier that you saw in the log. So I kind of mentioned that we're grabbing items out of this JSON file, and then we're preparing the script to use. And so let me show you that. And then if I forget, remind me to show you the environment variables after I show you how this script works, okay? So let's go take a look at the code here, and we'll go into folder check. And I set this up with the .sh file. That's the one that we modified. And I also have this JSON file alongside of it. Now, I want to be super clear about this. I chose this convention to use for my purposes, right? It does not have to be this way. I chose to make it this way because it made sense to me, right? And it follows a pattern that I'm familiar with. There's other ways you could implement this, but this is what made sense to me. The shell file contains the script, okay? So the only thing that's in this file is the script itself. The JSON file here has all the other metadata that I need in order to make the API calls to send the script up to Kanji, up to my MDM. And the way I've named it, I've created this convention where whatever the file name is, .sh, the same file name .json has the metadata for that script. And it just makes it easy to do a match. If I see a .sh file that's changed in that list, I can look for the same file name with the .json extension and know that I'm going to find the metadata that I need in that file. So it's just, I just want to explain, like, it was a choice that I made. If you want to make a different choice, you can. Okay, so let's look at what's in here. The name is the name that shows up in Kanji, right? So if I change this, switch to the editor. So let's change this. Okay, and we'll commit, and then I'm gonna bypass all the branch protection, right, and just commit directly to the main branch. If we go back here and look, you'll notice that the original name, like PSU MacAdmin script, whatever it was, it got changed to folder check because that was what was in the JSON. So I'm going to change it back to PSU script the next time it runs. This ID is the unique identifier for this script item in Kanji. Again, your MDM will have some kind of unique identifier for whatever item you're trying to update. Then there's some options that are unique to the MDM I'm using. So active, is it true or false? No enforcement means it's in self-service. It doesn't run automatically. I could choose other options. Your MDM will have other options that you'll need to select. Does it need to restart or not? Is it available in self-service? I could set this, I could change these things. The category, this is the ID of the category name, which is scripts in this case. And is it recommended? So again, like these are options that are provided by the MDM that I'm using. Whatever MDM you're using might have different options, but you could still follow this pattern of like creating all those options or listing all those options in an associated metadata file. Okay, so if we go back to the YAML for the workflow, this should make some sense now that we're using JQ to read the details out of the JSON file. You can see here like it's referencing the file name, but looking for the same file name with the .json extension, and it's reading the ID value out of that file, that unique ID. It's grabbing all the rest of the data, like the entire payload of JSON that's in the file, and shoving it into this data variable. And then I've got a couple steps here with the script that I think I'll show you in terminal. So, okay, we've got the folder check.sh file. So if I cat this, you can see that there's, sorry, I know the scrolling could get a little dizzy here, but you can see the script is pretty nicely formatted here. I've got line breaks, I've got some indentation, I've got other things that really make it a lot simpler for me to work with, and it's just cleaner and nicer to work with. Putting all of that text into a bash command that's using curl to call it is problematic, right? Because you start your curl call and you say, okay, I want to send this payload with the script in it, and you hit a line break or a new line in there, bash thinks the command is done, right? And it's ready to go. And well, I don't want I don't want it to send the first line of the script. I want it to send the whole script, right? And I'm going to get errors and stuff if I don't close it properly. So I've got to do a little bit of work here in order to take this script with the nice formatting and be able to use it in a bash file. Now, there's other solutions to this. You could use something nicer like Python, right? That gives you a little better, like the requests module in Python, and you have a lot more options to work with how you build your payload for the API call and whatnot. But I wanted to keep this kind of straight and simple, and I'm just using the curl command in bash. But it does mean now I've got to work around this idea. I've got a multi-line script file, and that's not, I can't just pass it in because that first line break, bash is going to think it's done. And so I'm going to do a little bit of work. So this is what you see here, where you see this print %q. So I'll just show you this here. If I do print %q folder check .sh. Oh, I didn't echo that. Sorry. Let's do that. Oops. Maybe it doesn't work the way I think it does on the command line. No, it doesn't. Okay. Well, you'll have to, printf, that's what I forgot. Okay, sorry. It's one of those things where you really do just lose your mind when you're in front of an audience. I've still not done it right. Oh, forgive me. I'm not going to try to figure out what I've done wrong live, but trust me that the script is working or this command is working, because when you see it here, I've forgotten the quotes. Okay, should we try it one more time and see if I could do it? Third time's the charm? Okay, all right. Yeah. So, no.
I think you need to cat the folder, check sh, and then
pipe it into it. Okay, because that's what it's. Thank you. This is because the way I'm calling it the other way is working. So like so. Are we feeling good about this? Yeah. Okay, we're getting close. But rather than spend the time figuring out why Weldon can't remember bash commands, just trust me here that I wonder if I just took this and did it, if I could print the script, but print that variable. But what it's doing here is that %q option is telling printf to take the file and escape all of the special characters. So it's taking the new lines and putting, the escape character n, and it's doing the same for tabs and quotes and everything else. So this is a shorthand way of just escaping all of the special characters, so I don't run into this problem where, I send bash this multi-line file with a bunch of special characters and it freaks out because it thinks the command is done, or it doesn't know where the terminator is, or whatever it is that we're trying to do. Okay, so the next step here is we're taking the I'm rebuilding the JSON. So I've already got all the metadata from the .json file, but I also need to include the script itself. So what this step is doing is it's taking the data, right? When data is the JSON payload or the JSON manifest as it exists in my repo, it's taking that JSON file and putting it into a data variable. Then I'm building a new JSON object or JSON variable that has the data, plus I'm adding the script. So now my new JSON is going to include the metadata that you saw that's on disk as part of the repo, and it's including the formatted script as another item in that JSON. So now I've got the full thing that I need. I have all the metadata and I have the script itself. And I've composed that together in this last step here. Okay. So now I can call curl. I'm going to patch or update an existing item. The data is the JSON, okay, the variable that I've just built, composed out of the metadata and the script. That's what's being sent as the payload. And now I've got these additional items here, which I haven't explained yet. Okay, var's base URL, and then the rest of the path to the API endpoint. And the ID of the custom item is part of the path in the API call. And then I've got authorization, where I've got another strange thing that I haven't explained yet, secrets.api token. So I imagine folks here could hazard a guess. What is the purpose of that base URL item that we can see here, and this secrets.api token that we can see here?
I guess so that maybe someone on your team can understand what it's doing without exposing what those variables are, if they don't have access, or you don't want them to know, I guess.
As part of the curl command, I need to specify the domain name of the server that I'm going to call. And I'm going to have to do that every single time. Now, that's not like secret information or whatever, but it is tedious to type it in over and over again. It's also, someone else brought up, the idea of like mistakes that you make, right? And I make plenty. You saw me do 3 in a row, right, in front of a live audience. And so having the base URL in an environment variable means that it's never going to be wrong, right? I'm always going to get it right. So as long as I suppose I could fuck up the name of the variable, right? But as long as I put that in right, I'll get it each time. So that's why I have it that way for that one. And then the other point that was brought up was, well, maybe you don't want other people on your team to see some of these details. So the API bearer token is a really good example of that. This token has the permissions to modify items in my MDM. Can you imagine any particular reason why I might want to protect that information? Yeah. Live on the edge, Weldon. It'll be fine. This is all recorded on the internet, on YouTube, right? Just put it out there.
You also mentioned script portable.
Yes.
If you have a dev server, you can use the exact same script against the dev server as against a prod server, because variables are different and pointed at different servers.
There you go. So the comment for the recording was you could set up different environments for different servers. So if you have a testing server, if you have a production server, right, you could create different sets of variables in each environment. If you remember back to the beginning here, where we set up how this GitHub action is going to work, we define the environment that it's going to use as part of this. So the GitHub runner gets spun up, it starts, and it does a bunch of things. This new Ubuntu instance is ready to go. it loads things from the environment that I've specified. So if I wanted to have multiple workflows that are being driven different directions or towards different targets, whatnot, I can create different environments to hold those settings. So if I go into GitHub settings, I'll just show you where this lives. There are environment variables here. So I've got this one set up. Okay, the base URL points to my instance and a special API domain name that's used, and then the environment secrets are defined here as well. So the bearer token for this API call is stored in this environment secret, and my base URL is stored in a variable. So these ones are, more, well, they're non-sensitive, right? It says it right here. These are for non-sensitive configuration data. These are encrypted environment variables. So this is a way, again, that I could share this repository with the intern on my team, with a junior engineer, someone who's coming up and trying to learn this stuff. I can give them access to this repo. They can make changes, see how it works, but they're not going to commit anything into production. They're not going to push anything all the way into production without me approving it because of the main branch protection. And they're not going to be able to copy out secrets like the API bearer token and do something off to the side that I don't know about, right? Okay. So a couple other important details in putting all this together. All right, so we've got I'm going to clear that so it stops reminding me that I forgot how to do it. But you can see that work. We do know that that was successful because of the result that we got. But also, if we go back into the previous action and look at the logging, here. I'm confused. Oh, that's because that was a different run. Okay. Should be here. We can see here here's the script item in the payload, and you can see here that we've got the special characters escaped. Okay, so the //n, so on. You'll see it show up with a bunch of times with tabs and new lines and everything else in here. Okay, so that's what that printf statement's doing, is it's reformatting the script so that it escapes all those special characters. So let's go back. Let's try this one more time. Okay. Oop, must be in the wrong spot. Oh, this is when your fingers are moving faster than your brain is. But I'll make another change just so we can see this again. Does anyone recall at this point? I know it's been over half an hour, but what is it? 2:38. Does anyone recall at this point what the other change I made was? I changed the name of the item in the JSON payload. So that metadata, I made a change there. So what we should see is when this runs again, okay, I'm going to save this. If I look at my git status, branch main, the .sh file has been modified. So I'm going to git add that and git commit with, updated the script one last time. And now that that's set, I'm going to push it to, oh, I made the change. Okay. I forgot I made the change in GitHub. So let's just do that. This will be, instead of pushing it from my local machine, we'll just go in here and do the same thing. So 2:40 p.m. and commit the changes. And again, I'm going to just bypass all that because I'm an admin on the repo and I can do that. I don't have to play by my own rules. So I've done that. And if we go here, we'll see that this new action has been queued up and the workflow run is queued. We'll see a runner get spun up in just a moment, and it's in progress. Now it's been running for several seconds. And if we go and look, we can see the progress. It's already done. So set up the jobs, run the checkout, compare the checkout against the previous one, get the list of changed files, filter that down for .sh or .zsh files that have changed, build that into a list, and then pass that list of files into this command. And so we'll see here again, okay, last updated by Weldon at 2:40 p.m., right? And then further on down, let's see if I can find it. Restart script, active true.
The name's on the
Top line, thank you. I skipped right over it. My eyes ran over ID and went on. So there it is, name PSU script. So because we changed that in the JSON, so if I go back to my kanji library, right, folder check, that should change now to PSU script. So using this workflow, right, it's not going to push anything. The way I've set it up, it's only going to push if I've changed the shell file, right, the script itself. But when it does, it's going to reference the current version of the JSON manifest and use those details as part of the API call. If you wanted to get more sophisticated, there's lots of different directions you could go, right? You could have it check, is the JSON manifest been changed? And if that happens, okay, then find the associated script file and go through a similar process, right? I didn't bother to do that for the demo. I just built it to look for the shell file and then find the JSON. But you could build it to look both directions and do that. If you had PKG files that you were storing in your Git repo and you wanted to upload new versions of the package into your MDM, you could do that. If you wanted to do that with custom profiles, actually it's a little simpler with custom profiles because profiles are text, they're XML files. They just have the .mobile config file extension, but they're text files. So manipulating text at the command line like we're doing here, pretty straightforward. You could do it in almost the exact same way that I've done here with scripts. You could do it with the image files, whatever it is that you're keeping track of. You're just going to have to modify your workflow actions to deal with that file type appropriately and do the right thing. There's it could be different API endpoints that you need to call in order to update each of those items. And so that's another place where you could build on this and say, okay, if it's a script file, go through these steps, right? And call this API endpoint. If it's a package file, go through these other steps and call this other API endpoint and upload the new package into that item. The piece that I want to get across is there's a bit of configuration here and there's a bit of convention. So the configuration pieces, like you need to use GitHub or GitLab or something like that and follow their instructions to set up the remote repo, set up your main branch protection and approvers, set up if you can have actions available, set up your secrets and your environment variables and all of that, right? Those are things you're just going to have to configure and follow the steps. There's room for you to use other people's conventions, borrow from mine, find other people's, invent your own, right, around how this is going to work for you. So I chose to put the script file and the JSON manifest next to each other with the same file name. Is just an easy way for me to keep track of them and show that they're related. But that's something I invented, right, in the sense that I didn't have to do it that way. So that is the end. So thank you very much, and hope that was helpful to you.